Hello and welcome to INE's CCI Service Provider version 5 lab course. Today we will look at OSPF version 2 network types. For some of you who do not know me, my name is Rohit Pardasani and I would be your instructor throughout this course. I have 5 CCIs: CCI in route switch, security, voice, collaboration and service provider. So as you know, in OSPF there are different network types. There are different types of OSPF connectivities that you could do between two routers. Like I said, there are 5 different network types. The first one is point-to-point. Then we have broadcast. We also have non-broadcast as a network type. We have point-to-multipoint. And finally, we have point-to-multipoint non-broadcast. Now, all of these network types, they have basically different use cases. Let's try and understand each one of them, where we would use point-to-point, where we use point-to-multipoint, or a non-broadcast or a broadcast segment. Now, point-to-point is by far the simplest network type. It is basically between two routers. Let's say if I have a back-to-back connection between two routers, I could set it up as point-to-point. A point-to-point network, as the name describes, is a link exactly between two routers. A packet sent from one of the routers will have exactly one recipient on the local link. There's never more than 2 routers on that one link. So you would never have like router 1 and router 2 and router 3 connected. It would just be 2 routers connected back to back. That's a point-to-point segment. In point-to-point, the convergence is much faster, obviously because there's no DR election in point-to-point. Neighborship is automatic. The hello packets are sent as a multicast, and the hello and dead is 10 and 40. Like I said before, there is no DR election and the neighborship is automatic. I do not need to give a neighbor statement as far as point-to-point is concerned. Looking back at broadcast network type, that's usually when you have multiple routers who are in the same subnet connected not directly to each other but through a switch. That's a broadcast segment. So anytime you connect 2 routers over an Ethernet or a gig interface, the OSPF will automatically detect that as a broadcast network type. If I connect 2 routers over a WAN link, like a serial connection, then the OSPF will automatically detect that as a point-to-point. So you don't really need to change the network type, it detects that automatically. So point-to-point is by default on a WAN link, and point-to-point is also by default on a tunnel interface. However, if you're doing something like DMVPN, then you may want to change that network type to a point-to-multipoint. As far as the broadcast segment is concerned, again, that's automatic when you connect 2 routers or more than 2 routers through an Ethernet segment or through a switch. So an Ethernet segment is an example of such a network. If you look at this diagram, I have 4 routers, router 1, 2, 3, and 4. They all are in the same subnet. However, they are not directly connected to each other. They are connected through a switch. So OSPF routers on a multi-access segment will elect a designated router, which is a DR, and a backup designated router, with which all non-DR routers will form adjacency. Now, why is the need for a DR in broadcast segment and it's not needed or it's not present in point-to-point? Well, in point-to-point, there are only 2 routers who are sending hello packets to each other. So there's no problem there. However, in a broadcast segment, there could be 2 or there could be more. Now imagine if router 1 sends an update, a link state update to router 2, and there's also router 3 and 4 in the same broadcast segment. What's going to happen? Router 1 sends a link state update to router 2. Router 2 will send that to 3. 3 will send that to 4 and to 1 and to 2. So basically the same information goes multiple times among these routers. So because of that, there's something called as to the DR election. And a DR gets elected to reduce the amount of LSA floods which would happen in that broadcast segment. Basically the same information would be sent to multiple routers from multiple devices. Exactly the same information. To avoid that, we have a DR election. So among all the 4 routers that we see in this diagram, one of the router gets elected as a DR, and the DR selection happens based on priority. If the priority is same, then it goes to the router ID. Priority by default is 1, higher is better. You can change that to maybe 255 if you want, and lowest is 0. If you make some router interface as priority 0, it would not participate in DR election. So one of the router gets elected as the DR based on priority or the router ID. Again, router ID higher is better. Once the DR is elected, the second router would be elected as the BDR, which is the backup designated router. All the other routers will be DR others. Now, a DR other would only form adjacency with DR and BDR. BDR just replicates from the DR. DR other would never form full adjacency with another DR other. For example, in this diagram, let's assume that router 1 becomes the DR. Router 2 is the BDR. Router 3 and 4 would be DR others. Now, both router 3 and 4 would form full adjacency with R1 and R2 because they are the DR and BDR. 3 and 4 would not form full adjacency with each other. They would be in two-way state. Now, if R3 needs to send a link state update or any information, he would send that to the DR. It is the DR's job to send that information to everyone else. So basically, in your broadcast segment, you having a DR and a BDR reduces the amount of LSAs that you would see in that broadcast segment. So if you look at this, it says that to ensure that the number of adjacencies maintained does not grow too large, a segment containing 10 routers would require 45 adjacencies to form a mesh, but only 17 when a DR and a BDR is in place. The hello and dead interval for broadcast segment is still the same like point to point. It is 10 and 40. Neighborship is automatic, but you must keep one thing in mind. If you have like a point to multi-point environment, you must always make your hub as the DR. You should never make your spoke as the DR. Always your hub should be the DR. Going back to non-broadcast network type. Now, non-broadcast, as the name says, it does not support broadcast, which means it does not support multicast. Now, OSPF sends hello packet as a multicast. In a non-broadcast segment, there's no support for broadcast, which means there's no support for multicast. So how do you establish OSPF adjacency? Well, in non-broadcast, the neighborship has to be done manually. So unfortunately, not all multi-access technologies support broadcast transmissions. For example, frame relay and ATM are probably the most common examples of non-broadcast segment. Here, the hello and dead is different from point to point and broadcast. The hello is 30 and the dead interval is 120. Neighborship is not automatic and DR election happens. So you must again ensure that your hub becomes the DR. However, the neighborship is not automatic. You have to manually give the neighbor statement on any of the router. Typically on the hub, you should give the neighbor statement. Once you give the neighbor statement, the hello packets are sent as a unicast, not as a multicast. So your OSPF adjacency would happen as a unicast and not as a multicast. Then we have point to multipoint network type. Point to multipoint configuration approaches the non-broadcast limitation in a different manner. Rather than trying to emulate broadcast capabilities, it seeks to organize the PVCs into a collection of point-to-point networks. Hello packets must still be replicated and transmitted individually to each neighbor, but the multi-point approach offers two distinct advantages. No DR and BDR is needed, and it emulates point-to-point links and can occupy a common subnet. So basically what's happening here in point to multipoint is everybody is in the same broadcast domain, but still there is no DR election. And it's still something like a point to point, even though they are in the same broadcast segment. So you'll have one hub and multiple spokes all in the same broadcast domain, but each spoke will communicate with the hub only. So if the spoke 1 wants to talk to spoke 2, it goes through the hub, unless you do DMVPN and that makes spoke-to-spoke talk directly. Here, the hello and dead is same like non-broadcast. It is 30 and 120. However, there's one change. No DR election and no neighborship. So basically, my neighborship would be automatic, and I don't need to give the neighbor statement. And the neighbor is, the hello packets are basically sent as multicast. Lastly, we have point to multipoint non-broadcast. This is basically a combination of point to multipoint and non-broadcast. The hello and dead is still 30 and 120. Manual neighborship is required, same like non-broadcast. You require manual neighborship, but no DR election, same like point to multipoint. That's why it's a combination of point to multipoint and non-broadcast. So let's configure our routers with different network types and look at the hello and dead and see if the neighborship comes up automatically, or do we need a manual neighborship command. Alright, so I have some routers here. I have R6, which is basically neighbors with multiple routers. If I do a show IP OSPF neighbor, R6 has 4 neighbors. 3 of them are IOSXZ, which is R3, R4, and R5. And 19, 19, 19, 19 is my IOSXR1. So R6 has 4 neighbors. They are all connected on their individual broadcast segment. So 3, 4, and 5, they all are in different subnets, different broadcast segment, different interfaces. Because I'm using gig port, this interface would be a broadcast segment. OSPF automatically detects your network type. So if I connect to routers using a gig port, it would be a broadcast segment. If I connect to routers using a serial or a WAN connection, it would be point to point. So let's do a show IP OSPF interface gig 1.619. Here is where I would see my network type. It is broadcast. My hello and dead is 10 and 40. There is a DR being elected, and the DR is IOSXR, and the BDR is R6. There's no DR other at this point of time because there are only 2 routers in that broadcast segment. So one router gets elected as the DR, and the second router is become the BDR. So IOSXR is the DR because it has a higher router ID, and R6 is the BDR. Now I could go and change this network type. If I go back to interface gig 619 and give the command IP OSPF network, and I could change that to point to point. If I change this to point to point, you would see that if I go back and do a show IP OSPF neighbor, my neighborship is up. However, it's not going to be stable because one side is still a broadcast segment which has a DR being elected, and the second side does not have any DR. So obviously my neighborship is not going to be stable. And if I look back at show IP OSPF interface gig 1.619, you would see that my network type has now changed to point to point. Hello and dead is still 10 and 40. And there is no DR being elected. So you can see here there's no DR. If I look back at IOSXR1 and let's do a show OSPF neighbor, you can see that I still have my neighborship with R6, and IOSXR1 thinks that R6 is the BDR, but there is no DR on that segment. So obviously, I would not learn any routes from that neighbor. Your network type must be the same on both the routers. Otherwise, it's going to be unstable. So let's go and change the network type on my IOSXR1. So let's do a show run router OSPF. So as you see that OSPF has already been pre-configured. I have not configured network type as of right now. XR1 is automatically detecting it to be a broadcast segment. So let's do a show OSPF interface gig 0000.619. As you can see here, the network type is broadcast. Hello and dead is 10 and 40. There is a BDR, and XR1 thinks that he is the DR on that segment. However, for R6, there is no DR because he's point to point. So my neighborship is not going to be stable. So let's go and change that by saying router OSPF1 area 0 interface gig 0000.619 and say network point to point. Once I issue this command, there would be no DR election now. Both the sides would be stable. My convergence would be faster because there's no DR election anymore. Let's do a show OSPF neighbor. As you can see, my neighborship is up and running. And if I do a show OSPF interface gig0000.619, you would see that my network type is now point-to-point. I could change this to be a multi-point also. My hello packets are still multicast, so both in point-to-point, my hellos would still be as a multicast. My destination would be a multicast address. Even in broadcast segment, my destination would be a multicast address. Let's go to router 6 and do a debug IP OSPF hellos. You would see that I'm sending a hello packet to XR1 on interface 619 as a multicast. So here is where you can see that I am sending hellos to 224.0.0.5 from my interface which connects to iOS XR1. Let's go and change this to be point to multipoint. So if I go back to router 6 and change my interface, so interface gig 1.619 to be IP OSPF network point to multipoint, you would see that my OSPF neighborship goes down because now my hello and dead is different. R6 has hello and dead as 30 and 120, and iOS XR has hello and dead as 10 and 40. So let's check this. On 619, you would see that my network type is point to multipoint. There is no DR election. If I look at iOS XR, show OSPF neighbor, I don't have neighborship with R6 because the hello and dead is different, because the prerequisite is that the hello and dead should be the same. So let's go to XR1 and go back to router OSPF1, area 0, interface 0000.619, and change the network type to point to multipoint. Once I change this, my neighborship should come back up. And if I look back at my OSPF neighbor, I have full adjacency with R6, which you can see here, and show OSPF interface gig 0000.619 should show me that my network type is point to multipoint and my hello and dead is 30 and 120. Again here, my hello packets would be sent as a multicast. There is no DR election in point to multipoint. However, if I change this to be a non-broadcast or a point to multipoint non-broadcast, in that case, there's no DR election. However, there would be a manual neighborship required. Let's just try with non-broadcast. I'm going to go back to XR1 under router OSPF1, area 0, and then interface would be 619 and network would be non-broadcast. Let's do a commit. The minute I do a commit, you would see that my neighborship again goes down with R6. They both have the same hello and dead, which is 30 and 120, but R6 is still point to multipoint and XR1 is non-broadcast. So let me go back to R6 now and change his network type to be non-broadcast. So IP OSPF network non-broadcast. So now they both have the same network type. Show IP OSPF interface gig 1.619. They both have the same network type. They both have the same hello and dead, which is 30 and 120. However, my neighborship is not going to establish, because non-broadcast means it does not support broadcast, which means it does not support multicast on that segment. So hellos are normally sent as a multicast. So we need to convert this to be a unicast. Otherwise, your neighborship would not establish. If I do a show IP OSPF neighbor, I do not have neighborship with XR1. It's stuck at two-way state. I don't have the adjacency with my iOS XR1. So for forming the adjacency, all I have to do is go to any one router. It could be iOS XR1, it could be R6. On any one router, I would have to go under my OSPF process and say neighbor, the neighbor's IP address, which is 20.6.19.19, and here I could specify the priority if I want, or just enter. So if I give the neighbor statement, now R6 is going to send him a unicast as a hello. So if I do a debug IP OSPF hellos, you would see that R6 is going to send him a unicast update on that link. So to R4 and to R5, he's still sending multicast, which you can see here. But to 20.6.19.19, he would send a unicast. So let's check that. So here is where I can see in the last line, sending hello to 20.6.19.19 from my unicast address. So now my source is a unicast and destination is also a unicast. Earlier, my source was a unicast, but destination was a multicast. Now both source and destination, they both are unicast. As you can see, my neighborship just came up. So you don't have to give the neighbor statement on both sides. Any one side would be okay. As long as your network type is same and your hello and dead is same, you should be okay. I hope this video was informative to you, and thank you for viewing.